Here we go, 3, 2, 1. Okay, we're going to be looking at dma060 sections 1 and 2. In sections 1 and 2, we're going to be working with exponents. So the most basic thing to begin with is that we would have a base value to a power. That power is called the exponent. If we have something such as -8 squared, in this scenario, what it means is -8 times 8, which is a -60. However, if I had given you negative out of a parenthesis squared, that would mean we would be multiplying -8, and a negative times a negative gives us a positive 64. So it's important to pay attention to. Okay, so when we have a parenthesis, it makes the difference between whether the first answer is a -64 versus this answer being a positive 64. This can be very important when you have to evaluate an expression. Evaluate this. So if I give you, let's say, 2 squared plus 5. If I were to give you this and I tell you if x is equal to a -4, okay? So if I'm going to do this problem, that would mean I have 2. I'm going to put the -4 in a parenthesis because the entire x is the number -4. So negative sign included is going to be squared plus 5. So ideally, all you need to do is you can use your calculator to do these. You can do 2 times -4 squared. That part is going to give you 32. And then we're going to add the 5 to it. That would give us then 37. So this first part is our 32 plus the additional 5 will give us 37. Let me show you on the calculator what's going to happen if I forgot to use my negative sign, the parenthesis with the negative sign. If I had just done 2 times -4 squared, just that part would have given me a -32, not a positive 32. And then when I add the 5 to it, it would have given me a -27. So can you see it would give us two completely different answers based on whether we utilize the parenthesis when we have a negative. So the important fact to remember here is that when you have a variable that's raised to a power, if that value is a negative, please put a parenthesis when you're substituting it into an expression. Our next bit of information is looking at the exponent rules. These are the things that you're going to have to commit to memory. If you have the same base and you are multiplying those bases, you are going to be able to add the exponents together. If you have a base and you have what's called a power raised to a power, we are going to multiply the exponents. What I'm going to do here is I'm going to list all of the exponent rules here on this one slide. Once I have done this, then I am going to do individual examples on a different slide for each of the different ones, okay? If we have a and b both in a parenthesis and it's raised to the power of m, that means this exponent applies to everything inside the parenthesis. Power of m, the b is also to the power of m. If we have bases that are the same, if my two bases are the same, we are going to use the quotient rule, which means we are going to subtract the exponents that we have here. They're going to be subtracted. Same as this, if I have a parenthesis and an exponent on the outside, it's going to apply to both the numerator and the denominator if both of them happen to be inside of the parentheses. Any base to the power of 0 is always equal to the whole number 1. If you have a value raised to a negative power and you're asked to not use negative exponents, you would take the variable, this base, put it in the denominator, and then the m would become just simply being as a positive. If you had it in this form and the negative was in it's going to come up to the top and be by itself. Another way I also like to do this would be if you have a base to a negative and a different base to a negative, what's going to happen is this one is going to drop to the denominator and be positive. If you ended up with a negative in the bottom, it's going to come up to the top and then become a positive. So I know this is a lot of rules to throw at you at once, but what's going to happen is throughout section 1 and 2, all of these are going to be looked at, and we're going to do examples of these where we are doing practice with each skill set. Okay, so let's go ahead and we'll start with the first one. When we have the same base, in this scenario, all I have to do is add the exponents, and you don't have to write this step with writing them out. I'm just doing that for your benefit. But if you add 3 and 6, that would give you 8 to the 9th. In the beginning, as you're doing these problems, they're not going to ask you to give a numeral. That will come later. In this section for right now, we are simply working with taking these and we are just adding the exponents. Okay? So for this one with the m's, the first one does not have a variable. Since there's not one written there, it's understood to be the number 1. It's understood to be the number 1. So for the m, we have 9 and 1 is 10. 10 and 3 more would be m to the 13th. Okay, now let's look at this one. So in this scenario, what we're first looking at is we have -2 times 3. Notice there's nothing outside the parentheses. So this is just simply multiplication. So -2 times 3 gives us -6. For my a's, I have a to the 7th and a to the 5th. 7 plus 5 is going to give us 12. For my b, I have 2 b's here and I have 1 b here. So 2 plus 1 is going to give us b to the 3rd. So if we look at our next concept, here we're going to take, this is going to be with the division. So in this case, we have 7 here, we have an understood 1 here. So what we have, 7 minus 1, is going to give us 5 of 6. If I have x to the 4th times x over x to the third. So in this one, before I can do the subtraction, I need to combine that numerator. 4 plus 2 gives me x to the 6 over x to the third. And then 6 minus 3 is going to leave me with just 3. When we have a power to a power, so here we're going to have x to the 5th to the 4th, 7 to the 4th to the 3rd, and 1 over x squared, all of this to the 5th, okay? So power to a power, we multiply. 5 times 4 gives us x to the 20th. Here, for the 7, that's our base. 4 times 3 is going to give us an exponent of 12. And here, 1 to the 5th, 1 to the 5th is 2, just the answer of 1. And with the x, 2 times 5 gives us 10. So that will be 1 over x to the 10th. Okay. Okay. So as we continue, they're just going to complicate it a little bit more. And as we do this, we have x squared, y cubed. All of this is to the 4th. So that means we are going to have, for the x, 2 times 4 is going to give us 8. And for the y, 3 times 4 is going to give us 12. If they happen to throw in a number with this, so let's take one where we have numerals in it. Now notice in this case, we have -2 and then it's to the 4th. So when you're utilizing your calculator, you still need to square, you need to take that negative sign, and when you raise it to the 4th power, it's going to be a positive 16. Okay? So that's going to give us here positive 16. And then x, 5 times 4 is 20. It's an understood 1 times 4, which is 4. And for the z, 2 times 4 is going to be the 8. If we happen to have this same scenario, and let's say we have x, y over 7, and all of this is squared. So that means our x is going to be squared, our y is going to be squared, and for the 7, 7 squared is going to give us 49. Okay, so that's really all of what we have in section 1. As we look into section 2, 2 is same thing, but the focus is primarily on negatives, having negative exponents. If we have, let's say, 2 to the -3, if you remember earlier, if we have a negative, that means it drops to the denominator. So this technically would be 1 over 2 to the positive third. And then if we simplify 2 to the third, 2 times 2 is 4. 4 times 2 would be 8. Let's do another where we have a negative. M to the -6 over M to the -2. So we have -6 minus -2. And now this is where people sometimes mess up. Oftentimes, if you're using your calculator, someone might do -6 and then just do, well, excuse me, they would do -6 minus 2. But that is not what our problem is. We have -6 minus, and we're subtracting from it -2. Minus a negative is going to become plus a positive. So -6 plus 2 is going to give us, in this case, an exponent of -4. When we do our final answer, we are not going to have this left with a negative exponent, what we're going to do is we're going to let it drop to the denominator and write 1 over m to the positive 4. Okay, let's try this. If we have 2 over y to the negative 6, in this situation, what we have is that this is not raised to a power, but in the denominator we have a negative. So if the negative is in the denominator, it's going to come up to the top. So this would be written as 2y to the positive 6. Okay, let's do 1 or 2 more of these. Okay, let's say we have 3y to the 5th over z to the negative 4. And then we're going to do 5x squared y negative 2 over z to the negative 7. Okay, so in this one, the only thing we can adjust is the negative exponent, and this is going to move up to the numerator and become a positive. Now in this one, the 5, the x squared stay where they are. Is there anything down here that's going to join them? That z is going to become z to the positive 7. This y to the negative 2 is going to move to the denominator and become y to the positive 2. Okay, and let's say just a couple more of these and then we will stop. So here's a good one. We have 5x to the negative 3rd y to the 4th. Let's make one that's going to give us a couple of steps to do. Okay, so let's say for this problem, everything here, I'm not going to simplify what's inside yet. I'm going to raise everything to the power. And after I've raised everything to the power, then I'm going to move things, okay? So I'm going to have 5 to the negative 2nd. With my x, I'm going to do negative 3 times negative 2 is going to give me a positive 6. For my y, 4 times negative 2 is going to give me a negative 8. In my denominator, 1 times negative 2 is negative 2. And for 8 times negative 2, that gives me negative 16. Okay? Now, with this 5 to the negative 2, that's going to have to drop to the denominator. So, if it drops to the denominator, it goes down here as a 5 squared. Okay? With these values, what we're going to do is subtract. So here for the, I'm going to say 6 minus negative 2. 6 minus negative 2 gives me positive 8. So x is to the 8th. For my y, I'm going to do negative 8 minus negative 16. Negative 8 minus negative 16. And that's going to give me also a positive 8. So all I have left, see, these ended up simplifying themselves when I did the subtraction, so they don't move again. Final answer is going to be 8x to the 8th, y to the 8th, and 5 squared is going to be over 25. And that is all of our first 2 sections. And when we meet again, we will move into polynomials.